Final part of section 3.1. We're going to look at just 3 examples, and I am going to take my time going through them, and I'm going to give you a couple of alternate ways to work them. The first way, and this is the way the examples in your book are worked, if I want to evaluate the tangent of 2 pi over 3, and by the way, you are not allowed to use a calculator because that is on the unit circle. So it's going to say, any other time I would say find the exact value without a calculator. That means you would have to kind of justify to me, where you get this from. So we'll talk about that. One way to do that is to convert it to degrees. So if you get stuck and you're not comfortable working with radians, you can just go ahead and convert to degrees. So first, we'll take the part A, tangent of 2 pi over 3, and we will convert it to degrees. So 2 pi over 3 multiplied by 180 over pi reduces to 120. So if we clean all of that up, we get 120 degrees. That means I'm really asking you to find the tangent of 120 degrees. Okay, well by now you should know enough or be able very quickly to figure out that is in quadrant 2, and it has a reference angle of what? 60 degrees. Okay, so 60 degrees is our reference angle. That means that it takes the place on the unit circle right over here, and that it has the ordered pair the same as 60 degrees, which is -1/2. Well, I'm sorry, 60 degrees would have +1/2, but over here in quadrant 2, the x values as well as the cosine values are negative. So -1/2, positive square root of 3 over 2, and a tangent value, remember, is square root of 3 for 60, so it's negative square root of 3 here. So once we figure that information out, we are able very easily to look at that ordered pair and know what that means, and know that this is the cosine, because it's x over r, and the r value is 1 for any point on the unit circle. This is sine, and this is tangent, and we're being asked for the tangent. So the answer to part A is simply negative square root of 3. That's the answer to part A only. For now, just ignore B and C. Personally, I feel like that's a lot of work, but it depends on how comfortable you are with radian measure, whether you can do it without converting it to degrees. So I'm going to show you now. I'm going to erase this, and I'm going to talk you back through it, and we're going to get the exact same thing without converting it to degrees first. I want you to know, though, that you can do it either way you want for now, but I do expect you to speed up, and the speedier you are with it, the better off you're going to be with things like ACT. Okay, so let's just sort of erase some of this stuff off, and let's start over. Tangent of 2 pi over 3. Well, let's think about what we've learned so far. If the denominator of the radian measure, and I know it's radians, not because it has the pi, but because it's lacking the degree symbol. If the denominator is a 3, a 4, or a 6, a whole pi, or a half pi, that means it's on the unit circle. So if I have 2 pi over 3, it's on my unit circle, and it has a reference angle of 60 degrees because it's over 3. So immediately, I know its reference angle. If I can figure out what quadrant it's in, I'm kind of done. So we see that it's 2 pi over 3. That's a little less than pi, and that's going to place it into quadrant 2. So that's the first thing we figured out. Without even converting it, we figured out that its reference angle was 60 degrees. And by looking at the 2/3, I was able to figure out that its quadrant was 2. And that will allow me to identify the ordered pair that goes with it, which is -1/2, positive square root of 3 over 2, with a tangent value of negative square root of 3. So just by knowing the reference angle, you should be able to figure it out within the positive or the negative. And then once you know the quadrant, you can put the sign on. So we know that the tangent of 2 pi over 3 has to be negative square root of 3. I prefer that method But if you're not fully comfortable with it, or if you ever get stuck or you're unsure, just convert it to degrees and then go from there. But you can see that we get the same thing, and it's basically the same process. To evaluate a trig function from the unit circle, you really have to know three things. You have to know the reference angle, you have to know what quadrant it falls in, and you have to know the ordered pair that goes with that reference angle and adjust the signs accordingly for that quadrant. That's part A. Let's look at part B together. Okay, so this time we're just looking at part B. So, we don't want that red. Let's go with green. Let's look at just part B here. Sine. I'm just not doing so well. Let's try again. Okay, it is definitely time for us to go home. I need a do-over. Let's just look at part B, and I am determined to highlight it, so give me a minute. All right, just this part right here. Sine of 3 pi over 2. Let's come out to the side and see if we can figure out what that is. The first way we could do it, and I'm going to do it both ways again. We can take the 3 pi over 2, and we could convert it to degrees. Now hopefully we're already starting to memorize these, so we're not going to have to do this for very long, because that one is indeed on your unit circle as well. So 3 pi over 2, convert it by multiplying by 180 over pi. The pi is simplified to 1. 2 goes into 180 90 times. 90 times 3 is 270 degrees. So basically, I am asking you to find the sine value of 270 degrees. So we know from our unit circle that that's right here, that the ordered pair that goes with it is 0 units on the x-axis and -1 unit on the y-axis. And that means that the sine of that must be -1 over the r value, which is 1. So -1 over 1 is -1. If you have your unit circle well memorized or you know enough about it, you don't really have to convert it to the 270 degrees. Think about it. We could just start here. We say that's half pi, because remember, every quadrant, every 90 degrees is a half of a pi. Half pi, whole pi, 1.5 pi. 3 over 2 is 1.5 pi. And that occupies the same spot right there as 270 degrees. And we can write our ordered pair down, and we can get there. So either way you do it, it's important for me when you're taking assessments right now that you show your work. Because if you don't, I can't really give you any partial credit. So be very careful about always showing work for these things, especially the ones that you're not allowed to use a calculator for. Okay guys, we have one more left. Just one more. We can do it. Unfortunately, it's the one that I'm not looking forward to because it's -4 pi over 3. And the negatives always throw a wrench in things. So let's turn to a clean page here. And let's start over with just part C. So part C. Cosine of -4 pi over 3. Okay. I think the first thing we should do is just go ahead and convert that to degrees. So -4 pi over 3 multiplied by our conversion factor of 180 degrees divided by pi. The pi is simplify. 3 goes into 180 60 times, and 60 times -4 is -240. So that is -240 degrees. So what I'm really asking you to do is to find the cosine of -240 degrees. Okay, some of you have shown me you're very good at counting negatives. I'm not the best at counting negatives. Sometimes I can do it. Sometimes I get my quadrants wrong. So if you're unsure, remember that we can take any negative angle. We can add 1 revolution of the unit circle to it and find a coterminal. So in degrees, 1 revolution is 360. So I could add 360 to that. And I would say, okay, really, I'm also saying that's the same as 120 degrees. And I could just evaluate the cosine of that. 120 degrees is on my unit circle. It lives in the second quadrant. And it has a reference angle of 60 degrees. And I kind of knew its reference angle was going to be 60 degrees because if you remember, if the original radian value is over 3, the reference angle on the unit circle is 60 degrees. So you should have kind of been looking for that, but once you see that it's 120, that's 60 away from 180, so that's your reference angle. So we're going to use the ordered pair that goes with 60 degrees, but adjust it for the second quadrant. So that is -1/2 square root of 3 over 2, and a tangent of negative square root of 3. I feel like we've used that point way too much. Should have done one with a 30-degree reference angle. Okay, so which one of those is the cosine? Cosine is -1/2, because that is x over r if you go all the way back to your definitions. So there's one way to work it. For most people, oddly enough, that's probably going to be the way you're going to want to work the negatives for a while. But I will show you some alternate things because it's important to me that you have another way to work it if you get stuck. So let's go through here and let's clear all of this off. And let's start over with part C. Cosine of -4 pi over 3. Okay, so automatically, right off the bat, it's over 3. I know that it has a reference angle of 60 degrees. So I've got that out of the way. From there, I have already narrowed down. Its answer is either 1/2 or -1/2. The question is just what is its quadrant? So that's what we're left wondering. We know its reference angle is 60 degrees, but I won't know whether its coordinates are positive or negative until I figure out the quadrant. So that's the question. -4/3. Two ways you can do this, and one is incredibly weird. The first way that we can locate that quadrant is I can simply start here at 0 and I can count backwards. This is -1/2 pi, this is -whole pi, and this is -3 pi over 2, which really, to me, I kind of need to see as a decimal, so it's like -1.5 pi. I'm looking for -4/3. Well, -4/3 pi is the same as I don't know, 1 1/3, so like -1.3 pi. So if this is -1 pi, and that's -1.5, -1.3 has to be about right here. So we can see that it is in the second quadrant. So that's how I would probably find the quadrant for this one. However, there is still another way to find that quadrant. I don't want to confuse anyone, but I do want to put this out there. If you want to make that negative angle positive when it's in radians, the way you find coterminal in radians is to add 2 pi to the angle. So let you think about that for just a second. If I'm gonna find coterminal to a degree, I add 360 degrees. If I'm going to find coterminal to a radian, I have to add the equivalent of 360 degrees, but in radians. So I'm going to add 2 pi. Now obviously that involves fractions and some pi's, and it just scares people. But let's try it anyway. We have -4 pi over 3, and I'm going to add 2 pi to it. That's going to have a common denominator of 3. So I don't need to do anything to convert the numerator of this one. I just keep it as -4 pi. Now 2 pi I need to convert by multiplying both the top and bottom by 3. So that will become 6 pi over 3. So I need to add 6 pi to this. Combine the numerators and I get 2 pi over 3. So really, that's the same. -4 pi over 3 is coterminal to 2 pi over 3. So if I ask you to find the cosine of 2 pi over 3, you should be able to look at that and see, we already know the reference angle is 60, but you can see now, if you weren't sure before, that because the numerator, when it's positive, is 1 less than the denominator, that it has to be in quadrant 2. So, hope that helped a little bit. So, that's another way to see that it's in quadrant 2. And once again, the ordered pair there in quadrant 2 is going to be -1/2 square root of 3 over 2 with a tangent of negative square root of 3. You should never forget that point anymore. And the cosine value is -1/2. So there you have it. Something that could be done in 30 seconds, and I took, I don't know, 7 minutes to teach it to you. I hope it increases your understanding. So we'll stop there. If you have any questions, just let me know and we can figure out a way that works definitely for you, and I can help you practice on that. That wraps up section 3.1.